A big picture for the works we present here at IROS 25 goes mostly into the direction of how can we support underwater localization as an enabler for higher autonomy levels that we need for underwater or marine platforms to perform more autonomous tasks.
At IROS 2025, we had the honor to interview Dr. Daniel Duecker from TU Munich.
Hi, I'm Daniel Duecker. I'm Senior Scientist and Research Group Leader at TU Munich. I'm their group lead for the Environmental Robotics Lab, which is basically research underwater, on the water, on the ground, in the air. So we build robots for all those domains. We try to use them as a combined system for environmental monitoring, environmental protection, and data sampling for any application there. Here at IROS 25 in Hangzhou, we present 3 papers in marine robotics, specifically underwater and surface robotics there. Like one paper, for instance, is we demonstrate how underwater manipulation works. I think in total have 100 pick-and-place setups and show how much accuracy we achieve there with that system. Another paper, on the other hand, is like just going a bit into more detail on the manipulation thing is how can we, for instance, estimate the wrench, so forces and torques acting on the underwater robot without actually using a force torque sensor on board, so simply from IMU data. The third paper though, marine robotics, so surface and underwater robots, there we demonstrate with a low-cost acoustic modem data where we determine the ranging to build an underwater localization system where we have multiple surface platforms driving on a river or a lake, and they provide localization support for underwater platforms. A big picture for the works we present here at IROS 25 goes mostly into the direction of how can we support underwater localization as an enabler for higher autonomy levels that we need for underwater or marine platforms to perform more autonomous tasks. Core challenges, especially in the marine domain, is that we really have to accept that core, let's say infrastructure is not available as it's in the air. If you look on your smartphone, you have like GPS, GNSS support for localization you can use for any navigation system. Underwater, we just have the challenge that Wi-Fi and GPS is just not available, like they're attenuated at that range underwater. So we need to come up with other systems, other technologies that support us, because still our robot needs to know where it is and we need to know where our robot is underwater. So an example is the acoustic ranging as an underwater localization system, but on the very small level, so the ranging can be like meters, hundreds of meters range. On the other hand, we go to very fine and accurate localization, and which we, for instance, then need for these highly accurate and precise manipulation tasks, where we really go down to centimeter, sub-centimeter range to then like pick and place items from one to the other. And you see there the full range that you actually need from the localization perspective. When we look on how to use systems that, for instance, those that we present currently here at IROS in Hangzhou, if you look how we bring this to real world, like out of our lab, out of like field testing into real world applications, we really have to improve on robustness and also like on how to make these things reliable and usable for the end user. But for instance, somehow our paper may a bit contribute to that. We also need to understand also the limitations of what current systems are able to do. In our research, in my research, in the marine domain, the underwater domain, localization is unfortunately not a given, so we just do not have GPS available. And this especially for lab testing, for exploring upper bounds that are reachable with today's technologies. Motion capture is a core technology to that. The results we get with the motion capture system is kind of then the gold standard in a positive way. And then we see, okay, how good do we perform with respect to that? My group is always open for bright and curious minds joining our team, either as like undergrad researchers, PhD students, or postdocs. The main, I think it doesn't even matter so much whether you have a mechanical engineering, computer science, or electrical engineering background. I think one of the core things I'm looking for is that the persons are passionate about their work, are curious, and also what I find super important are questioning the results, and also are interested pushing these robotic systems to their limits, so that we can actually see, okay, these are current limitations, then aim to do this step beyond what is currently the state of the art. And I feel like this kind of passion and excitement about these systems is really a must-have